Chapter 2, Lesson 2 of Geometry, we're going to look at biconditionals and then definitions. And biconditionals is the word conditionals, which we studied in Lesson 1 with the prefix by meaning two. So actually we're going to be looking at two conditionals. And we're going to learn how to write those biconditionals and then how to determine if a definition is a good definition or not. So writing biconditionals, we read this paragraph and it says when a conditional and its converse are true, so that's the condition of the conditionals. The conditional, and its converse have to be true. And if they are, we can combine them as what we call a true biconditional. And this biconditional is a statement that we're going to get by taking out the word if and then and putting in the phrase if and only if. Alright, so that kind of summarizes what a biconditional is by definition. Then we need to learn how to use it or how to make our own. So the conditional and the converse both have to be true, and if they are, we're going to join them together, or we're going to make a new statement using if and only if, and that's going to be our biconditional. So the first thing is, example, we have to have a conditional that's true. So let's do an example. If if two angles have the same measure, then the angles are congruent. Is that a true conditional? And yes, it is, because if two angles have the same measure, then they will always be congruent. We then have to write the conditional of this, or at least consider it. So we switch the hypothesis and conclusion to get the converse. If two angles are congruent, then the angles have the same measure. And we consider, is this true? Well, this statement is also true. If two angles are congruent, then they have the same measure. So because both the conditional and its converse are true, then we can go ahead with the next step, and that is to write a biconditional. Okay? Now, in order to write the biconditional, we're going to take the two conditionals, and the paragraph said we're going to combine them into one conditional, and that's not technically what we're going to be doing. What we're actually going to be doing to write this is we are going to combine them, but in a way where we're not going to have this long sentence. So here's how it's going to happen. You're going to go back to the original conditional, and we're going to take out the word if, okay, and we're going to take out the comma and the word then, and right there is where we're going to put the phrase if and only if. So we're going to take out, if I just kind of fade this out, you'll notice how it changes. We take the original conditional and we notice that it has the hypothesis. Two angles have the same measure, and then here's where the phrase if and only if, and then we have the conclusion, the two angles are congruent. So we talked about combining these into one, but actually we're just taking the first one, the first and original conditional. We're taking out the word if, and we're taking out the comma and the word then, and right here we're placing in the phrase if and only if, and this is what we consider a biconditional. And it says that the conditional and the converse are true. So no matter how you read it, both are going to be true. Now again, one note, you can only do this if the conditional and the converse are true. So the problem solving part of your homework is to discover, is the conditional true and is the converse true? That's the problem. If they are, then you go ahead and write the conditional. If they're not, then a biconditional is not possible. Okay, so let's do another one. If 3 points are collinear, then the points lie on the same line. Is that a true conditional? Well, yes, that is true. Now, what is the converse? Well, the converse would be if the points lie in the same line, then the 3 points are collinear. That also is true. So because both are true, we can take the next step and write the write the biconditional. And again, to write the biconditional, we're going to combine them, but in actuality we're going to take this first conditional, we're going to remove the word if, we're going to remove the comma and the word then, and we're going to fade those out, and in their place we're going to put if and only if. So 3 points are collinear if and only if the 3 points lie on the same line. So this is a biconditional. Alright, I think I have one more example. Here's the conditional. If a number is divisible by 20, then the number is even. And that is a true statement. That is a true conditional. We then must inspect the converse. converse would be if a number is even, then the number is divisible by 20. Well, that's false, because I can give you a counterexample. The number 2 is even, but 2 is not divisible by 20. And when we say divisible, we mean evenly divisible. And so this converse is false. So a biconditional is not possible. So don't write a biconditional unless you've done the inspection and determined that the conditional and its converse are both true. Okay? Now, because we can go from two conditionals into one biconditional, we should be able to go in reverse. And that's one of the things about mathematics. We're always interested not in just doing one thing going one way, but also applying a reverse operation or something that allows us to go backwards. So we should be able to go backwards. Now, if we take a look at what we're talking about, a biconditional is a conditional statement plus the if and only if plus the converse that gives me the biconditional. So if I take the biconditional and I take out the if and only if, that should leave me the conditional and its converse. It's just a little algebra there. So here, let's go in reverse. 3 points are collinear if and only if the 3 points lie in the same line. So we should take out the word if and only if, and that's going to give me, and put back in the phrase or the word if and then the comma then. So I go from 3 points are collinear if and only if the 3 points lie in the same line. I take out if and only if, and I put the if back in the beginning, and I put the comma back after this word and then. So if 3 points are collinear, then the 3 points lie in the same line. That gives me my conditional statement. Okay, and then to get the converse, I simply reverse the hypothesis and conclusion, and so now I have the conditional and its converse that be made up the biconditional to begin with. So I can go with two conditionals and make a biconditional. I should be able to go with a biconditional and determine the two conditionals where it came from. So one more example then. Whoops, I already gave you that. Two angles have the same measure, so again we want to take out the if and only if. We're going to put in the comma and the word then. That gives me the conditional, and then the converse simply switches the hypothesis and conclusion, and so then I have this. So two conditional statements to make up a biconditional, and two conditionals that we can get from the biconditional as well. So this is kind of what it ends up being mathematically. A biconditional takes if P then Q, and then if Q then P, and makes it a biconditional P if and only if Q. So this symbol here means if and only if when we're looking at it in logic notation. And again, that's something that's just kind of nice to know. I won't really quiz you too much, if at all, on that anyways. So P represents a hypothesis, Q is the conclusion. Okay, so that's how you write a biconditional. Make sure you have to meet the conditions. Conditions true, converse is true, then you can write your conditional. And if you have the conditional, you should be able to go in reverse as well.